In this lesson, we'll look at solving simultaneous linear quadratic equations using the completing the square method. Solve the pair of equation y plus 3x equal to 8 equation 1 and y equal to s squared plus 2x plus 4 as our equation 2. Solution. Remember, step 1 is always make y the subject formula in any of the equation. But here we already have that from equation 2. So we have y equal to s squared plus 2x plus 4 as our equation 2. So let's step 2. Step 2 is substitute the value into the other equation. In our case here, it's equation 1. So we plug in y equal to s squared plus 2x plus 4 into equation 1. We'll have s squared plus 2x plus 4, then plus 3x equal to 8. Step 3, collect like terms. We'll have s squared plus 5x minus 4 equal to 0. This gives a quadratic equation in one variable, which we can now solve using either completing the square method or quadratic formula or graphical method. Here we are using completing the square method. So our step 4, we take the constant to the right hand side. We'll have s squared plus 5x equal to 4. We'll add the square of half of the coefficient of x to both sides of the equation. We will have s squared plus 5x plus 5 over 2 all squared equal to 4 plus 5 over 2 all squared. The left hand side becomes a perfect square of x plus 5 all squared. So we have the square of s plus 5 over 2 equal to 4 plus 25 over 4, which will give us the square of x plus 5 over 2 equal to 41 over 4. We take the square root of both sides of the equation. We have x plus 5 over 2 equal to plus or minus the square root of 41 over 4. This will give us s equal to minus 5 over 2 plus or minus the square root of 41 over 2, since we have taken the square root of both sides. So we have x equal to minus 5 plus or minus root 41 all divided by 2. We have x equal to minus 5 plus or minus 6.403 all divided by 2. Remember our either or. So either x is equal to minus 5 minus 6.403 all divided by 2, which implies that x is equal to minus 5.70 to 3 significant figure, or x equal to minus 5 plus 6.403 all divided by 2, which implies that x is equal to 0.70, 3 significant figure. Step 5. Use the values of s to find the corresponding values of y from the linear equation. We can also do it from the quadratic equation, but it is far easier to start to use the linear equation. So we have for x equal to minus 5.70, we have y plus 3x equal to 8 will give us y plus 3 into minus 5.70 equal to 8, which implies that y minus 17.1 is equal to 8, which implies that y equal to 8 plus 17.1, which implies that y is equal to 25.1, to 3 significant figure. For x equal to 0.70, y plus 3x equal to 8 will give us y plus 3 into 0.70 equal to 8, which will give us y plus 2.1 equal to 8, which will give us y equal to 8 minus 2.1, which will give us y equal to 5.90, three significant figure. Therefore, the solutions to the given equations are x equal to minus 5.70, y equal to 25.1, and x equal to 0.70, y equal to 5.90. Example 2. Solve the pair of simultaneous equations below. S squared is equal to 4 minus y as our equation 1, and x is equal to y plus 2 as our equation 2. Solution. Step 1. Replace the value of x from equation 2 into equation 1. We will have y plus 2 all squared equal to 4 minus y, which will give us y squared plus 4y plus 4 equal to 4 minus 1. Step 2. Collect like terms, we have y squared plus 5y equal to 0. Here we can notice that it must not be that y is made the subject formula before substituting the value and solving in terms of x. S can also be made the subject formula and be substituted to solve in terms of y. So proceeding to step 3, add half of the coefficient of y to both sides of the equation. We have y squared plus 5y plus the square of 5 over 2 equal to 0 plus the square of 5 over 2. Then make the left hand side a perfect square to give us y plus 5 over 2 all squared equal to 25 over 4. Step 4. Take the square root of both sides of the equation. We have y plus 5 over 2 equal to plus or minus the root of 25 over 4. Y is equal to minus 5 over 2 plus or minus 5 over 2. Either y is equal to minus 5 over 2 minus 5 over 2, which gives y equal to minus 10 over 2, which implies that y is equal to minus 5, or y is equal to minus 5 over 2 plus 5 over 2, which implies that y is equal to 0. Step 5. Substitute the value of y into equation 2 to obtain the corresponding values of x. For y equal to minus 5, we have that from x equal to y plus 2, x will give us minus 5 plus 2, therefore x equal to minus 3. For y equal to 0, x equal to 0 plus 2 implies that x is equal to 2. Therefore, as x is equal to minus 3, y is equal to minus 5. And as x is equal to 2, y is equal to 0.